Okay, we're going to get started here. Thank you guys all so much for joining and attending today. My name's Dalton Kramer. I'm the growth strategist here at Armorock. Today, we're going to go over a plant tour, behind the scene look at how to manufacture our polymer concrete manholes and lift stations. So without further ado, we'll get started. Quick overview of what we're going to touch on today. So we'll start with going over who is Armorock. So for those of you who are joining us for the first time, this will be a good opportunity to touch on kind of who we are and what we do. Next, we'll go into a step-by-step plant tour. After that, we'll talk about some expansion news, which is really exciting. And then we'll wrap it up with some Q&A and then a 10-question quiz at the end. For the Q&A, please ask your questions throughout the entire presentation and we'll answer them throughout. That little screenshot toggle I put there, that is where to put your questions. The chat feature is disabled, so make sure to put your questions in the Q&A chat. And then for the quiz, we're going to be doing a Kahoot. For those of you who don't know what a Kahoot is, no worries, we'll explain it at the end. And then our top 3 winners will get some Armorock swag as a gift. So stay tuned for all of that. Likewise, if you're here for some PDH credit as well, the QR code will be at the end. So quickly here, introducing our speakers. So we do have 2 speakers today. First, we have Jared Johnston, tenured Armorock employee, account executive in Florida. Next, we have Tom LaRue, a newer member to our team. He's the National Director of Solutions Engineering, and he's also going to share a little bit about his department that is new to Armorock. So I will hand it over to them now.
Thanks, Dalton. Appreciate all of you joining us today. As Dalton mentioned, my name is Jared Johnston. I've been in this industry for 20 plus years, started my career in project management, and I went into work for Geneva Pipe, the sister company to Armorock back in the day in 2010, and then transferred over to Armorock in 2017. And I'm excited to introduce our product to you today.
And I'm Tom LaRue, as Dalton mentioned, the National Director of Solutions Engineering. Prior to joining Armorock, I studied civil engineering at Purdue. I was on the design side of civil projects for about 10 years. I know many of you are civil engineers working those designs. I've been in those cubicles on those projects before. Then for the last 10 years, I've worked with various stormwater and wastewater manufacturers, product management, market management, evaluations, things of that nature. But excited to be with Armorock and growing the solutions team. So aside from myself, we've got a very talented group. Chris Juman's a longtime Armorock employee and engineer, has worked in deep engineering roles with the plants, a wealth of knowledge for the team, for the company, and now for the customers. Alec is based in the Orlando area. He's another longtime employee. He's served a number of roles, very instrumental now in the market along the East Coast. And then Drew Tanner is based in Salt Lake. He, like the other 2, a longtime employee, has provided a ton of value internally and is now sharing that knowledge externally. Currently traveling in the Portland area, doing a number of presentations, drumming up support for polymer in the Northwest. So please reach out. We're happy to do lunch and learns with local jurisdictions, with engineering firms. But the goal of the solutions team is to provide an engineering solution to the corrosion problem with the jurisdictions, the water districts, municipalities across the country. We'll go into how polymer solves that problem today, but that is our goal. It's an engineering-based solution, not a one-size-fits-all solution, tailoring it to what your jurisdiction needs.
All right, thanks, Tom. All right, let me do a little introduction to who Armorock is and why we're here. And to understand who we are and where we're going, we need to understand the past. And it really starts with the man you see there in the blue shirt. That's Vince Buccio. He was 2nd generation precaster out of Utah, Orem, Utah to be exact. And his father started Geneva Pipe and Precast in the 50s. Vince, when he came out of college in the 90s, had saw that their family business was losing market share, specifically in concrete pipes and wastewater, and then in the utility structures, the access structures like the manholes, lift stations, etc. Their market share was going down, and he wanted to turn that around. So he reached out to people in the industry that were coming up with solutions, and he bought a lining company. And we started spray lining our concrete structures with those rubber type of coatings we commonly see around. Unfortunately, those have a minimal life expectancy when it comes to H2S and the corrosions that we're dealing with. So he had to abandon the idea. He went to cast-in liners next. That's where they cast the HDP liners into our product. And inevitably, that H2S, the Theobacillus bacteria, would find a way behind those barriers and break down our material, and we weren't able to warranty them. And the last ditch effort was admixtures. Admixtures is designed to be cast into your product. It fights the MIC, so microbial induced corrosion. And we quickly found that the parts per million that we were dealing with in the system was too much for that also. If any three of those Band-Aid type products would have worked, we would not be here speaking to you today introducing Armorock. But we had to do a full stop to that and transition to a full stop solution. That's what we're going to introduce to you today. Also, while we're going into this next size, please write in your questions. We love questions. If you stump Tom, we'll come up with a special gift for you. So see what we can do to stump Tom here today. He's the smartest one on the team, and I'd love to see him stumped.
Thanks, Jared. I appreciate the challenge that you're tasking the audience with. So Jared gave the high-level overview of the history of Armorock, and we'll discuss the root of the problem that Armorock is addressing, corrosion in the wastewater system. And really began about 50 years ago as sanitary sewer and wastewater sewer systems were separated, and there was an effort to reduce the I&I in the wastewater systems. Started using higher performing products with better joints like PVC in lieu of clay pipe. And saw those I&I numbers go down. There was less rainwater getting into the system, less groundwater getting into the system. But the result of that is the concentration of the effluent flowing through the system increased, leading to an increased concentration of H2S gas. As the parts per million of H2S within the system increased, the susceptibility, the likelihood of corrosion also increases. Portland cement will begin to corrode as the ppm of H2S gets over 10 ppm, which is not a very high level. So it didn't take much reduction in I&I to really see upticks in the rate of corrosion. So as the H2S levels have increased, the rehabilitation costs have also increased. And this is a multifaceted problem because, again, the H2S levels are increasing, then the age of the systems are increasing. Over 45% of wastewater infrastructure is over 50 years old. Last week, I was in the Los Angeles area, and the city of Pasadena, almost proudly on their website, proclaims that over 20% of their system was installed before 1900. So over 125 years old in that instance. So as those structures age, the maintenance interval logically increases. Couple that with an increase in the H2S concentration, so corrosion is increasing, so the maintenance interval, further shortens. It's a constant battle of rehab, repair, and that is unsustainable for jurisdictions. The costs are simply too high. It's eating away too much of the budget. And the problem really is that the solutions that Jared talked about that the pre-Armorock explored all relied on Portland cement-based concrete. Lining and coatings, there's still Portland cement-based concrete as a core ingredient to the product. And Portland cement is susceptible to H2S corrosion. It is corrosive. So over time, anything that is done that involves Portland cement will not be successful. So what Armorock has done and what the polymer concrete industry has done is engineered a better solution by eliminating Portland cement from the material matrix to actually have a product designed for the environment. And we'll go through those key ingredients now. So the key ingredients, starts very similar to traditional concrete. We use small aggregates and sand. You'll see the small aggregate to start the picture. Our aggregate tends to be smaller than typical concrete. We get a tighter matrix, but small aggregate. We use fiber reinforced rebar. That's what's seen here. The fiber reinforcement is non-corrosive, so nothing in our structure, inside or out, is susceptible to corrosion. We use resin. That's the most important piece. In lieu of Portland cement, that's the binder. That's the glue. and it removes the corrosive component, replace it with resin, a non-corrosive resin that again provides that binding and without the corrosive aspect of Portland cement. We saw briefly the silica sand, the small aggregate sand, similar to what's used in concrete. Make sure it's silica sand, non-corrosive sand. These are non-corrosive quartz or granite, small aggregate. So nothing inside or outside of the structure is susceptible to corrosion. It's all completely inert. That's the key difference between polymer concrete and Portland cement-based concrete. It's just a better solution for the environment in which it's being installed.
Tom, we just had a quick question come in from Jennifer. She wants to know, and this is probably getting ahead a little bit, but it's always a valuable question. What is the life expectancy out of polymer? You mentioned that concrete, we see it's over 50% or 48% of the system's over 50 years old now and is breaking down at a high rate of speed. What are we expecting polymer to last in this industry?
That's a great question, Jennifer. Thank you for sending that in. And we have a 50-year corrosion-proof warranty. That is uniform throughout the polymer industry. It's a requirement for our ACI spec. So that's the minimum design service life is 50 years. What actual life cycle testing has shown is the true design service life is hundreds of years. There's not a known failure mechanism. The product is completely inert. It is inert day one forever. So it's not going to become corrosive 50 years in. So chemical corrosion will not be what brings down polymer concrete. The structural capabilities are very impressive. We have a minimum 10,000 PSI compressive strength. So it's not the failure mechanism in hundreds of years is not the dead load or over time of roadways, the live load of traffic because of that impressive compressive strength. Very high tensile strength. So the hydrostatic loads and the forces around the structure and the ground are not the known failure mechanism. So we'll see, but right now, as that testing evolves, right now, hundreds of years, and that gives the engineers, the jurisdictions, when the product's specified, you're specifying a product that will last a lifetime.
We had one other question. Sorry to interrupt there. Asking about our aggregate source. What is it as far as the rock? What type of rock is it? And then one you might add to that, and this is just for the audience use, is it the same type of aggregate across the country throughout all our plants?
We use locally sourced quartz and granite. The key is it needs to be non-corrosive aggregate sources. So the actual, mines, the quarries where that rock comes from varies. It's expensive to ship rock. So we use locally sourced, as local as possible, quartz and granite rocks as that for the aggregate source. Good question. That's down in the weeds.
Thank you. The rocks you see going in the video that's a river rock. It's a quartz. This happens to be in the Florida plant, which is our common rock here.
Yeah, please keep the questions coming, utilizing that QA feature on the top of the screen. Jared and I have a good time answering the questions and seeing that audience participation.
Okay, the Pico machine. This is actually my favorite thing to talk about, and everyone who knows me knows I love to talk. This gives us the abilities to do things that other producers of polymer and people in the precast industry cannot do. We're the only people that use a Pico machine, which is a 7-axis robot. That 7-axis robot allows us to go from your cocktail designs straight into production and come up with the exact dimensions of what you want. So as you're looking at this happening here, please think outside of the box where it could be a benefit to you and your municipality. And it all starts with foam. We take that foam, we use our 7-axis robot here, and we cut that out. The reason we use this is because every municipality in the nation has a slightly different standard. Some people like their pipes to come in 3.5 inches. Some like them as much as 6. That's called the pipe bed. Some use cast-in gaskets or boots. Some use bolt-in boots. And this gives us the abilities to match to your request. We don't ask you to match what we can do. And it gives us the ability to make monolithic bases. And the importance of building a monolithic base, whether it's a wet well, lift station, siphon box, or a manhole, is to eliminate any potential of I&I of getting into your system. Now here there's making a three-way, and you can start to see that shape happening there. This is going to be the opposite of what you see when it's finished. You can also see how smooth those transitions are. By making smooth transitions, we eliminate any potential agitation of the effluent going through that product. And when we cut down agitation, we cut down H2S. So smooth transitions are helpful there. Now, H2S will not affect our product. As Tom pointed out, we have a 50-year warranty on our product, but it surely will affect the rest of your system. So we want to do our best to help maintain that. Can you pause it right there, Dalton? This is a really good example of a pipe bed. On the left-hand side of the image there, that is about a 3.5 foot or 3.5 inch step in. That's where the pipe is going to set and match up to that invert perfectly. Again, eliminating that agitation and giving us the abilities to fix that. You also see the only steel in our product. We love to say we're 100% corrosion proof, and our product is, but for those that are astute and are paying attention, that is an A anchor. That's a galvanized steel. Now that will not affect our product. Eventually, it will be covered up with polymer grout in the finished product. And currently, that is the only steel in our product. Unpause. Thank you, Dalton. Once we're done creating this product, you can see again how smooth it is. We're going to put it into our jacket or our form. We have forms that range from sizes to 48 to 192, and we'll show that in this next video here.
Jared, we had a couple questions come in. Nikki asked what the yellow coating is on the foam.
Oh, yeah, that's a great question. It's a trade secret. We don't totally give that away, but I can tell you this: it is sprayed on and it keeps the resin. The resin actually has a very high heat to it. Can we, oh yeah, you can keep that running in the background. Thank you. We can keep that running in the, we can spray that product with this material, and that gives us the abilities to keep a library of that product. So for instance, if you make a 0180 or a 090, a common use invert, we could use that up to 5 times before we recycle it. So when we're done using our foam, we'll grind it up. You can see it's in the makeup here in the background. You'll see what it looks like when it's ground up, much like what you'd put in a beanbag chair. We'll grind it up. We heat it into smaller blocks. We send it back to the manufacturer, and then they re-steam it into larger blocks, charge us a lot more money, and send it back to us. But we like to be sustainable in what we do, and that's a big part of it. Great question, Tom. Is there anything else?
Yes, TJ asked if there's an added cost for custom designs that use the Pico machine.
There is not. So CAD designs, we do not charge for in that. The added cost would only come in the depth of the invert. So let's say you're really creative and create what is called a beaver slide. Now, this is something the rest of the industry can't do, at least in the levels that we do it. And a beaver slide of being an internal or external drop, if it's within a certain circumference of the first joint, we can have that lateral have a nice sweep like a roller coaster coming into there. Rather than just to have a free fall of the effluent, we're going to make a perfect transition. So the CAD does not cost extra money there, but there would be extra material in that scenario. Also, I see J.O. has their hand up. We can't answer over that, but if you want to text or type in your question in the Q&A, it's up in the top of the screen there. We'll be happy to answer that for you.
Okay, and then Aiken, I think, had a follow-up on the quarries and asked about the sustainability of the mines and quarries.
That's such a good question. So when we first came into this industry, we spent a great deal of time finding an aggregate source that was inert to corrosion. When we first started building our polymer products, we used a standard aggregates. Those aggregates were also corrosive. Not only the Portland cement would break down, but we typically use sandstones and limestones, which most precasters are using across the country, which are easily susceptible. My big word just scooped up today. We're not holding up to what the causes were in this industry. So we replaced those. And we would go around and test them in a muriatic acid, and we would put the aggregates in there and make sure there was no corrosive nature. And that's where we came up with these. And luckily, quartz and granites are readily available all over across the country.
Great. And then one more kind of follows up on what you were saying. There's a question from Dennis about any chemicals that are not suitable for polymer concrete. Now I'll address that. Dennis, no chemicals in wastewater systems will corrode polymer concrete. If there's unique applications, we're working on a project now with a pharmaceutical manufacturer. We can work with our resin providers and do evaluations to make sure that those unique environments that are atypical of sanitary sewer systems, that there'll not be any problems. And we're not going to recommend our product in any situation where it's not going to be successful. We appreciate all the questions, so please keep them coming utilizing that chat feature.
Great. Next slide, please, Dalton. Oh, pouring. We're already there. Fantastic. On the pouring feature, this is exciting. So now we've taken that yellow product, as we identified earlier, we put it inside of our forms. And this is where we're going to come up with the monolithic. Can we pause it there for just a moment? This is where we give us the ability to make monolithic bases. Again, if you note, let's circle one of those pipe bed areas on those, Dalton. There you go. That's where the pipe penetration is going to be in your structure. And the width of that is determined by the type of pipe you have. So if you have an HDP, it's going to be a specific thickness, SDR, another, clay pipe, RCP, etc. This is one of the great features. The next one there is in that same area, tells you how far the pipe can come into that structure. And more importantly, and this is very important, you can control the amount of deflection you have in that pipe. So for instance, a traditional boot has 7 degrees of deflection, 3.5 degrees left, right, up, or down for a total of 7 degrees. If your municipality has a different standard and you only want to allow 2 degrees of deflection, we can tighten up that invert to match exactly what you want. Okay, we can unpause there. As the material pours in, this is a self-consolidating, very much like a self-consolidating concrete, but this is a resin-based product. We have little to no air entrapment in our product. Pause right there. Tom, you talked a little bit earlier about the FRP bar. Could you take a moment and talk about the importance of this bar and why it makes us different from the rest of the people in the industry?
Yeah, absolutely. So this is a great shot of that rebar matrix in the base of the structure, providing additional structural, specifically tensile support in the base. Again, it's the fiber reinforcement. So if a question we get all the time when talking to jurisdictions when they're looking to utilize the product on new development is, what if we need to channel into it, add a new line and carve a new channel? And that's completely fine. You'll be carving through 10,000 PSI concrete, but you can carve through. You're not going to expose any materials that will invalidate our 50-year warranty. Nothing inside or out susceptible to corrosion. So you're free to add a new channel for a new line with no problem. You can also see those rebar ties are plastic, so not traditional metal twist ties. It's steel, or that will be made of steel. These are plastic ties. So again, nothing corrosive being introduced to the material at all.
Thanks, Tom. Yeah, we have lots of great questions coming in. Unpause that, Dalton. Let's keep going here, and we'll answer. If we're ignoring your question, we will answer it before the end of our show. So after the material's poured in, polymer concrete has the capabilities to cure out very quickly. In fact, we traditionally are pulling out of our molds between an hour and an hour and a half of time, which gives us the abilities to rotate our molds upwards of 3 times on a shift. As the product's pouring in, you saw on the large diameter structures, it's done elsewhere in the shop. We carry in 2-ton buckets. In this scenario, we move the mold onto our turntables and we pour the product in a circumference around that product, slowly building that up. Again, that will push all the air entrapment capabilities out of that product. The less air entrapment you have, the less chances you have for I&I going through that product. There's some of the hoop designs going in. Those will drop in as we're building up that structure. We started with the base FRP bar that you saw, and we'll finish off with an FRP rebar in our lid. It is important to note that all of our products are HL93 load rated. We do not require any soil to get to the strengths. Lastly, once we're done, we'll put in the former here. That's for the bell and spigot former, and that represents the top of the product. So they'll finish pouring up to that blue grade there, and that creates our bell. And then again, they'll finish it off with the last bit of reinforcement. They do have little gray HDPE spacers on there to make sure that is perfectly aligned inside that structure. And then within the next hour and a half, we're moving this product around our yard, putting it into our inventory.
Great, Jerry. We had a couple questions come in that I think we can address right now. Pranshu, and I apologize in the pronunciation, asked, what temperature do we need to use for melting resin and mixing it with the aggregates?
That's an interesting. So resin comes in a liquid form, so we don't need to melt it in that scenario. But we do need to keep our temperatures controlled in our building. And we typically try to stay between 60 and 90 degrees in our building. That can be challenging in some of our summer climates, especially in our West Coast plants. And the cold temperatures, for whatever reason, Texas gets awfully cold, and they have challenges there where we have to run heat. That gives us the capabilities to be a precast structure. But that's a great question. Thank you.
There was two more parts of that question. What is the ratio of resin and aggregates in the mix?
That varies depending on the mix design, but typically we like to be anywhere between 12 and 30%, depending on what we're trying to achieve.
And then I believe you mentioned it, how quickly polymer concrete mix starts setting. And that's, 60 to 90 minutes.
That's right. And we could potentially speed that process up, but rarely would we want to do that. For high quality product, we are shooting for an hour to hour and a half, depending on the temperatures inside our building.
And then Talia asked, why do we pour upside down?
Fantastic question. Specifically the spigot. We want the most important part to be highly tuned, have no flaws. And that would be the spigot. The spigot is where our rubber gasket goes, and that will make sure no I&I is coming through that joint. Our tolerances are exceptionally tight compared to precasters, and that is the most important part of our product.
Yeah, I think that's all for now. We'll address a few more toward the end, but thank you all for putting those in.
Dalton, if you'll switch slides here. So the finishing product. Our company has really made great strides in the quality of our product. And we're going to show you a good example of that. This is just a typical mold. This is actually one of our older ones. Those have been replaced now. That's the quality of our product. Can you pause on that picture for a moment? That product is a virgin product. It just came out of a mold. And as you notice, and as you look through these photos, you'll see very few of them that have little to no patching. That's the key. In fact, our goal this year was to hit 80% of our product to have no patches. And that's where we're going to finish out the year. Next year, 2026, we're going for 90% of our product, which is form to whole, which means we give it to you, the municipality, with no patching. There's nothing wrong with patching polymer, but municipalities, just like when you buy a new car, you don't want Bondo on there and a respray. You want to know that product was perfect from start. And that's where we're going as an industry. And we're excited to lead the way there. Unpause, please. When the product shows up to you, it'll obviously be marked with our Armorock name on there. It'll also have the job information, which you see in the background there, the size of the product and the height. And it's important to mark those products. Again, it has a 50-year warranty. We encourage municipalities to keep track of that date so you can know for sure how long that product has been in your ground. As you see those in the background, you can see one or two little patches here and there. And that's typically, if we are doing any patching, it's very minimal. And that's because of the quality of the resin that we're pouring in there. In all of our yards, we inventory product. We inventory cones, risers, flat lids, bases. standard products. We also, where we're specified and work with municipalities, are going to start stocking lift stations, etc. Something that's never been done in the industry before.
Couple more, these should be pretty quick questions. Theo asked if the foam stays inside the completed structure. It wasn't shown being removed in the videos.
Yeah. Yeah, we actually have a vacuum that will suck out that invert, and then we'll put that back on the shelf and stock that away until we have another identical manhole request. And if it sits there too long, we grind it up and reuse it again. So there is no foam in the actual product as it goes out the door. All there is rock, the aggregate sorts, the quartz or the granite, the resin, silica sand, and fiber reinforced rebar, which, by the way, is an ACI 440 rated rebar. It's also commonly used and approved by DOTs throughout the country.
And then Noah asked, what are our typical lead times?
I love lead times. This is a differentiator, and polymer has a massive advantage. As I mentioned, we can rotate molds up to 3 times a day. Our company-wide goal is average jobs below 15 days, any size of job. That's a very big ask, and our polymer production teams have hit that goal this year. Our lead times are very quick. We are the largest polymer producer in the world, and we're very proud of our lead times. In emergency scenarios, we can do much better. Because of the speed that we can do things, we commonly are seeing projects be turned around in 24 to 72 hours, depending on where it's shipping to in the country. But let me make sure I identify what an emergency is. When a contractor forgets to order something is not what we're identifying as an emergency. We're referring to municipalities. When they have lift stations or manholes implode in the middle of the street and they go on bypass. Bypass costs so many thousands of dollars per day, and they're holding up traffic around. That's an emergency. And that's where they're red flagged to our product. And we streamline that through our process to make sure those municipalities can turn their system back on quickly and efficiently.
And then one more, Eli asked if we can cast in place.
It's a good question. I'm going to smile really big on that. We currently cannot cast in place, but wink, wink, nod, nod. It's coming soon. And we will be the first on that. I'm probably going to get yelled at for saying that, but if I was to start the rumor, yes, someday you will be able to cast in place, but currently we cannot. But we do have the capabilities to send out some of the largest projects known in the industry today, which will typically more than surpass the need for cast in place.
All right, I think there's a few other in there. We see those, but we will address those at the end. Wanted to address the ones that are more directly related to the videos that we're showing, but there is some other good ones in the end that Dalton will cover when we get there.
Tom.
Yeah.
Capabilities. This is another great capability of what we have. As you can see at the bottom there, we'll do 48, 60s, 72s, all the way up to 192s. 192s, an example of that is on the left-hand side, and the right-hand side of the images there. That's a 16-foot diameter structure. The one specifically there you see in the picture was 137 feet deep. That kind of shows the capabilities of polymer. And that wall did not need extra reinforcement. That shows the strengths of polymer. And then you saw the 7-axis router. Look at the unique inverts on the left and right there. That shows the capabilities and how smooth those transitions are of what we can do there. Please think outside the box. Don't think precast when you're doing our product. If you can design it, we can build it. And then, of course, we'll do boxes in whatever size we can ship. So it just comes down to the capabilities of shipping when it comes to box structures. Florida plant expansion. We started our plant here in Florida about 3.5 years ago. Our plant was first built in the 60s, and it was used for clay brick. It was in a U shape, and we took off the left side of our U and rebuilt that plant. And in that plant, we're going to have the capabilities to do those 16-foot structures that we spoke about. We commonly ship those large structures all over the country. People are always surprised that we can ship such large projects around, but we can. It's difficult, but we have abilities to do so. But our goal is to have these capabilities in all of our plants. Florida is our second plant with the 16-foot structure capabilities, and we can create 80,000-pound parts out of this building. And if you're interested, feel free to pull out your camera, take a picture of the QR code there on the right. That will be the sign-up sheet for that. We're going to have our grand opening of this division on the 14th. There will be live tours that day. We're going to show a lot of innovations that we haven't even shown in any of these other videos that we're excited to bring into the industry. There's several changes that we believe are going to be the future of sustainability, and we'll be pointing them out during that tour. A few of our sustainable partners in business will be there when it comes to the caps, EJ style ring and covers, etc. And we're excited to have you out there for a barbecue. And there's going to be lots of great gifts that are going to be a giveaway. So come and join us at that plant expansion party.
A couple more quick ones. You get fired up talking about the party. How often, Amy's asking how often we do compression tests?
Oh, that's a great question. We do that 1, 7, and 28 days. And those are called our cylinder breaks. It's a lot of fun to see. At that party, we are going to have that machine running through that, and you can see the cylinder breaks. One of the specialties of a cylinder break is our minimum strengths are much greater than precast, and we want to show that off to you so you can see those. What does it look like when one breaks, and what are we looking for to make sure that that quality is as high as possible and gives you the strengths needed. So 1, 7, and 28 day breaks on those.
And then Marty asked, you mentioned the Florida plant expansion. Where are our other plants?
We have currently Boulder City, Nevada, and then Sulphur Springs, Texas. And we own 2 other properties across the country that we aren't prepared to announce yet, but it's coming soon, and product has been ordered, and we'll be announcing them hopefully in the next year.
Great. And thanks for that background on the tour and again, all the questions and what the solutions team's excited about. I know Jared's excited about his grand opening party. We're excited about the technical stuff, the ACI specification for polymer concrete. This was released a couple months ago. It's the first national specification for polymer concrete. It's something that engineers, jurisdictions across the country have been asking for. It's finally arrived. This is an excellent document. You folks on the call, regardless of your position, you can rely on this to specify polymer on your projects and get a truly open bid. It levels the playing field for all polymer manufacturers and requires the minimum performance requirements that we've talked about today. Jared just mentioned considerably stronger than precast. It's a 10,000 PSI minimum compressive strength for polymer concrete that wants to meet this specification. Those have minimum tensile strengths and heat resistance. Most importantly, all materials to certify to the specification must pass an ASTM test for corrosion resistance that includes 6 strong acids immersed for 112 days, and then there's a visual inspection, a compressive test to ensure a loss of strength within bounds, and a weight to make sure no increase or decrease in mass. Any product that meets this specification is going to check all of those boxes. You're going to receive a high-performing product, and this allows the competition that's going to help make sustainable infrastructure, allow the manufacturers to compete on cost, on quality, on lead time, on service, all those things where Jared really thrives and the Armorock team really thrives. Allow us to compete there, allow our competitors to compete, and get an open competition to help save those jurisdictions money.
Tom, we had a question come in from Amy, and she specifically wants to know, is this a sole source specification?
Amy, it is not. This is truly an open specification. We kind of talked a few times today about the fiber rebar. That is not an ACI requirement. The ACI requires reinforcement, but the manufacturers or the owner can dictate the type of reinforcement. We prefer the fiberglass reinforcement because it's corrosion proof and has the same yield strength as steel. Some of our competitors save a few dollars and use steel throughout, willing to sacrifice that internal potential for corrosion.
Another
But also,
question.
actually, the lead author for this specification was not an Armorock employee, and so he certainly was not giving any any advantages. We made sure that he wasn't giving his firm any advantages as well.
We had another question from Ryan specifically towards the corrosion resistance. The question was, he hasn't seen that for ASTM. Does concrete have the same type of testing that we're required in the ACI spec, or is this a more difficult test system than what we've seen in the industry to date?
That's a great question. Traditional concrete does not follow the ASTM testing requirements for corrosion. They wouldn't pass. They have that fatal flaw of Portland cement, so they do not participate in that test. That is just one demonstration of polymer concrete going above and beyond. Higher compressive strength, higher tensile strength, and the corrosion resistance. It's not a standard that concrete will ever meet. The traditional concrete, Portland cement concrete.
That's actually on our sales team. We love to talk about that, and it's great to have a specification that's asking for more than what's out in the industry currently through the ASTM standards. So we have higher corrosion resistance. Obviously, we ask them for more compressive strength, more tensile strength, and we're doubling everything that's been put out there before. So our products are superior in every way, and this is a great example for you to make sure you're getting what you wanted. Thanks, Tom.
Yeah, good questions. So mentioned, we've talked about the sales team. The sales team's growing just like the solutions team. They're covering the country, working with jurisdictions, with engineers, with contractors on projects, walking lines. Take a moment and look at those names, jot down those phone numbers. You can also reach out on through our website. But they are eager to help. They're very, very busy working on projects and spreading the word of polymer. And this solution, people are eager to hear about it. They're eager to learn. They're eager to try it. It's truly snowballing. You can see that with the investments we're making in the plants. The momentum's there. It is that good of a solution. The engineering is sound, and the sales team on the screen is excited to be a part of it.
Yeah, I'll add to that really quickly. If anyone has a product that they think would be a good fit for our product, and we believe there's lots of them out there, please reach out to this team, challenge us, let us see where our product fits into theirs. We'll be happy to provide budgetary pricing, whatever is necessary to prove our product to you and your municipalities.
Okay, questions. There's quite a few. You're going to lead these, Dalton?
Yes, I'll jump in here. So to kick us off here, we do have a question from David. He's asking a question about coring into our product, and can you still penetrate with a new pipe after production? And if so, is there anything that needs to be done specifically to patch that penetration?
I'll handle that one. That's an easy one. So yes, you can core through our product. As we mentioned, we're 100% corrosion proof from wall to wall. There is no liners, coatings, or admixtures that can be affected by coring through our product. In fact, even our FRP rebar that has previously mentioned, if you core through that and it shows, it will not be affected. So there's no realigning of products that needs to happen there. If you have annular space that needs to be filled when you're done, you can simply use our polymer grout. We supply that with all of our projects. It mixes up a lot like a Bondo to a car. It hardens up in 35 to 45 minutes, depending on the temperatures outside, and it becomes an integral part of our product. So you won't have separation there, and you can mold that into any shapes that you want.
Great question. Next question here is from Jason, and it's around drop manholes. Can you just dive into that a little bit, and what process, procedures, capabilities on that?
Yeah, for sure. I did actually see that drop manhole in several locations in questions there. We can make exterior drop manholes or interior. If they're shallow enough in depth, then we'll suggest using that beaver slide we talked about earlier with those nice transitions. If it's an exterior one, some municipalities like us to actually take the 90-degree sweep and cast that into our product. When we cast that into our product, you eliminate any potential for a leaky joint. A lot of times when you field set those pipes, if they aren't set properly, they could have some issues. So that's a quick solution. And then we'll work with you on inside drops of any shape or design you have, and make sure the chafing is in the right direction to catch that effluent as it comes in.
Perfect. And then I see James's hand up. If you could put your question in the Q&A chat, that would be great. And then
Let me ask one really quick here as I was reading through these. Sorry to interrupt, Dalton. There's one from Jesus, and he specifically wants to know, are the joints tested at the plant? This is something that we're working towards. And we are going to change the industry in here. And yes, we are working with testing all our joints at the plant. And we're working towards a vacuum test that we're looking forward to announcing next year. But those of you that come on our plant tour will see our testing machinery that we're using to currently do this. And this gives you the ability to know that when a product goes out the door, we know that that joint is exactly what you expect. So you will not fail any vacuum test.
great question. Thanks for jumping in there, Jared. Next question here is from Richard. He's asking if you can raise the height of a manhole after it's been set.
Tom, you want to take that one?
I don't know if he's referring to raising the base or adjusting to grade. For adjusting to grade, Armorock makes grade rings, and there are several third-party suppliers that make grade rings. So if you need those final steps up to pavement, those products are available. As far as adjusting in the field, that would be very difficult. I haven't seen that done out. You've been around longer than I have, Jared. I don't know if you've seen that.
Yeah,
that don't you have to lift it out.
Yeah, there is a couple ways you can do that. Obviously, grade rings are the easiest adjustment. Most municipalities allow a minimum of 2 grade rings upwards of 18 to 24 inches. So you have a lot of room there. In our designs, we typically leave 6 to 8 inches worth of grade rings, so you have your adjustment there. If it's further than that, we can switch out risers. Obviously, we make risers in all sizes up to 96 inches, and we can cut them down in 1-inch increments if necessary. And then lastly, when it comes to cones, if you're in a low profile situation, we do make low profile cones in our system also. Great question.
Perfect. I have a few questions here about strengths and the strengths of polymer versus bare concrete. Can one of you guys jump in on about that?
Yeah, so minimum concrete we typically see on plans is for traditional concretes 3,000 or 4,000 psi. The minimum ACI standard for Armorock for polymer concrete is 10,000 psi. So that's compressive strength. So more than 2 times the compressive strength. For our HS20 and HL93 loadings, we use 8,000 psi in those calcs, and then there's additional safety factors built in through LRFD and the other evaluation methods. But you'll have the minimum 20%, the strength reduction factor from 10 to 8, and still be at least twice the strength of concrete. That allows us those burial depths, the narrower walls, and those improved performance characteristics that you see.
I had another one here I was going to add, and I'll probably answer this, and it made me giggle. I love good questions. This is someone who clearly knows our product and knows our product well, and it's from Atchen. I'm probably saying that wrong. I'm from Utah, so my spelling and math is not good. Your black pale polymer kits, can it be made more flowable on job sites? So interestingly enough, we do like to please our customers. Making it more flowable, the best way to do that is controlling the temperature, making sure it's up to a decent temperature. 80 to 90 degrees under your car heater will really make that more flowable, but then your set time is going to be a little quicker. But that is something that we've heard from contractors before, and we are working on better polymer grout kits for the field. And the part that made me laugh is he says he's burning through drill bits. He's referring to the strength of our product. Our product is strong. In fact, as our strengths show, it's typically 3 to 4 times stronger than concrete. And so, yes, you can burn through things. So as far as that, it's never going to get weaker. We are the strongest in the industry. It's going to stay there. As far as wearing out your equipment, just slow it down and let it eat a little longer. It takes about a third longer to core through our product than it does concrete, and drilling needs to be the same. Slow it down and it will be a little easier.